Hello everyone. Let us see next example of application of ordinary differential equation. We are studying the applications to electrical circuit. The next example, let us see when the switch is closed in a circuit containing EMF, that is electromotive force, that is voltage E, resistance R and inductance L. The equation is given by, this equation is already known equation. It is already given in the example itself also, where circuit contains L, E, R. It is a RLE circuit. The equation, differential equation, is L di by dt plus Ri is equal to E. What is the question? Find I as a function of t. We have to find I means we have to solve this equation. And second question, sub question, is how long it will be. How long means the time. We have to find time. How long it will be when the current reaches one half its maximum value. When the current reach to its half of the maximum value, then we have to find the time if electromotive force E is 6 volt, R is 100 ohm and L is 0.1 Henry. Okay. Now let us start with the first question. We have to solve this equation first. The equation of RLE circuit is L di by dt plus Ri is equal to E. It is given in the example. If it is not given in the example, still also we have to mug up this differential equation. Then it is a linear equation in I. Therefore, we have to divide this L, R, E. These capital letters are constants. And what are the variables only? I means current and T is the time. These are the two only variables. Rest of all alphabets are constants. Therefore, this is number. Divide this number by this. So, to this whole equation we get di by dt plus R upon L I is equal to E upon L. Call this equation number 1. This is obviously linear equation I with respect to T. Okay, this is I, this is also I, and rest of the constants. Okay. Now P is for linear equation. We know the procedure to find out the solution of linear equation. We have to define P and Q. P is nothing but coefficient of I, that is R upon L. Q is nothing but RHS side E upon L, which is a constant only. Now we have to find out integral factor or integration factor is equal to e raised to P this dt. P value is R upon L. R upon L is a constant. Therefore, integration of 1 with respect to T is T. dt is T. RT upon L. This is the integrating factor. Therefore, solution is instead of y there is I, instead of x there is t. Solution is I into integration factor. This I into integration factor is equal to integration factor into q dt plus c. Okay, this is the formula for linear, for the solution of linear. Now put the values integration factor and q here. Integration factor is this and this. Q is E upon L. Now where to solve this integration? E upon L is these are the constant. Take outside of the integration. Only T e raised to RT upon L is the function. Exponential integration is e raised to RT upon L divided by RT upon L. Derivative should be divided here with respect to T. R upon L is a constant. Therefore divide by R upon L plus this is the integration constant C. Now this L and this L goes to the numerator. Cancel with this E. We get E upon R e raised to RT upon L plus C. This is the solution, theoretical solution. Call this equation number 2. We have to find out now integration constant C. And we know initial conditions when T is what are the variable? T and I are the variable. We have to put the initial conditions in the variable only. Initial condition means when time T is 0, current should be 0. When time T is equal to 0, I is equal to 0. This initial condition we have to put in the solution. We get I is equal to 0. Therefore, 0 is equal to E upon R. E raised to 0 is 1 plus C. Therefore, C is equal to, take this term on LHS, we get minus E upon R. Now put this value of C in the solution. Solution becomes I is equal to I into E raised to RT upon L is equal to E upon, these two terms are same. C value is minus E upon R. Take E upon R common. We get E upon R e raised to RT upon L minus 1. Therefore, divide throughout the equation by e raised to this term. We get I is equal to E upon R. Division by e raised to RT upon L makes this 1 minus this makes 1 upon e raised to rt upon L. This rt upon L in the denominator comes to the numerator as minus. Therefore, this is the final solution of our question. Now we have to find out the solution for the second sub question. How long? Therefore, write down the first. We know how long it will take. Current reaches half of one half means half its maximum value. So that first we have to find out maximum value of I. Now when current is maximum means current increases when time increases. Variable current compare to time. We have to uh, find the condition when I is maximum. I is minimum value of I means current is 0 when time is equal to 0. This is the minimum value of current. When current reaches to maximum value, it should be find out on the basis of time. As time increases, current increases, right? Therefore, current will be maximum when t tends to infinity. When time tends to infinity, then and then only we get the maximum current. We have to find that by putting t is equal to infinity in our solution. Therefore, put from 3, that means this from 3 solution, put t is equal to infinity, we get I maximum, that is maximum current, E upon R is equal to E upon R into 1 minus e raised to this t is equal to minus infinity. Minus infinity into anything is minus infinity. Okay, now we have to solve. And we know I maximum becomes E upon R 1 minus it is 0 because e raised to minus infinity is 1 upon e raised to infinity. Anything raised to now some number into raised to infinity means infinity is equal to 1 upon infinity is the identity which is defined identity whose value is 0. That's why its value is 0. E raised to minus infinity is always 0. Therefore answer for I maximum, that is maximum current, is E upon R. Now we have to find out maximum current when it reaches to half, 1/2 of its maximum value. Therefore, I maximum by 2 means half of the maximum current is equal to E upon 2 divided by 2 both sides. Put this value in equation number this 3. Okay, what we get? E upon I maximum becomes half of the maximum becomes E upon 2 upon R is equal to E by R into 1 minus e raised to minus R. We cannot put t value of time because we have to find out that e raised to minus RT upon L. This means we have to put we are putting here the maximum current value, half of the maximum current value, and corresponding that to that we have to find out time. Now from this equation we have to find t, small t. Therefore by solving this we get E upon R gets cancelled, half is equal to 1 minus e raised to minus RT upon L. Again e raised to minus RT upon L becomes, this term gets on this, 1 minus half is half. Therefore take to cancel out this e, take log on both sides, we get minus RT upon L is equal to log 1 by 2. Now therefore t is equal to take r minus r and L on that side, we get minus L upon R log half. Again we have given already values of E, L and R. This E is an extra value, it doesn't help in our solution, it is just an extra condition. We have to put value of R and L. Therefore put R and L here, we get minus 0.1 upon 100 log half. Calculate on calculator, this log means ln log. Okay, it is not log log in calculator, ln is there because it is the base e, log to the base e, that's why it is the ln log. Ln half we have to find out on calculator. We get this 0.006931 time, and time is standard unit is second. Now put this in proper manner so that 6.919315 into 10 raised to this 4 digit plus minus 4 seconds. Okay, this is the second equation, second answer for our second value, second question, half question. Okay, now let us see next question. The equation of an electromotive force in terms of a current I for an electrical circuit having resistance R. Now electrical circuit contain R, capacitor C, and electromotive force, namely RLRCE circuit, and the equation is given by E is equal to Ri plus integration I upon C dt. Find full stop. This is the given condition. Now we have to find current I. We have to solve this equation and we have to find this I at any time t when E is equal to E naught sine omega t. In this case, E is specifically given E naught sine omega t. Now first of all we have to make this equation into differential equation, so that we have to cancel out this integration. To cancel out this integration, obviously both sides we have to make the reverse process of integration, that is derivative. Okay, derivative with respect to t. Now given thing is equal to, this is the equation. Now Ri plus, take this side on the LHS, this is the integral side, that's why, and put the value of E as it is given, E naught sine omega t. Okay, now to cancel out this integration we have to differentiate above equation with respect to this t. What we get? R is remember, capitals are constants, only variables are I and t. Current and time is the only variable, rest of all omega t, omega E naught, R, C, everything is constant. Okay, R is as it is, differentiation of t, I is di by dt, plus in derivative integration gets cancelled, I upon C is equal to E naught, and sine derivative is cos omega t into this omega. Okay, now divide this. Now we have to solve this equation to find out current I. Now divide this equation by R, we get this equation. Call it equation number 1. This is a linear equation. Obviously to find out solution of linear equation we have to define P is coefficient of I, that is 1 upon CR, Q, that is whole RHS. Okay, now integrating factor is e raised to integration P dt. P value is 1 upon CR, is a constant, take outside, integration of 1 is t, e raised to t upon CR. Therefore solution is as it is, I into integrating factor is equal to integration of integrating factor into Q dt plus C. Now we have to put the terms, integrating factor as this, and here also this, and Q is this total term, plus integration constant, don't forget this C. Okay, now we have to solve this equation. Integration is with respect to t, therefore we have to take E naught, W and R constants outside of the integration, because these are constant. Integration e raised to t upon CR cos omega t dt plus C. Now we have already know this integration. This is a standard formula for integration, e raised to ax cos bx dx, e raised to ax upon a square plus b square into a bracket a cos bx plus b sin bx, where a is coefficient of exponential, that is x coefficient, and b is coefficient of angle x. Okay, here a is coefficient of t, that is 1 upon CR, and b is coefficient of cos angle, that is omega. Therefore put this value here in this equation, we get the solution as, consider this integration separately first. Okay, e raised to t upon CR cos omega t dt is equal to e raised to ax, that is e raised to same term, e raised to t upon CR upon a square plus b square, that is this square plus this, into bracket a cos bx 1 upon CR cos omega t as it is, plus b is omega sin omega t. Okay, now simplify this, cross multiply, c square r square plus omega square c square r square whole divided by c square r square turns to numerator. Therefore it becomes I LHS side is equal to E naught upon omega upon R as it is, and this is the c square r square comes to numerator, rest of the terms as it is, plus integration constant C. This is equation number from equation number 2. Okay, now 1 r gets cancelled from this, therefore only cancel this 1 r, rest of the all terms are same, plus C. This is our solution. Now to find out only I on LHS side, Divide this total term by e raised to t upon cr. We get I is equal to, from this term this gets only cancelled, or rest of the terms as it is, plus c upon e raised to t upon cr comes to numerator as minus e raised to minus t upon cr. This is our most simplified solution. Okay. Now let us see next. A voltage E into e raised to minus 80. Voltage means E value is given in terms of e raised to minus 80 only. Value of E is given, E into e raised to minus 80. Okay, voltage is applied at time 0 to the circuit containing inductance, resistance, and that means this is a LER circuit. Full stop. This is the given thing. Now show that what is the question? Show that the current at any time t, that means we have to find current, and we have to show that the current is this. Okay. Let us start with the circuit. Equation of RLE or LRE circuit is this. This is a standard equation. Okay. Divide by L, we get this equation, and value of E is given, e into e raised to minus 80. Okay. Call this equation number 1 because E is given here. Okay. Now integrating factor is e raised to, same as earlier, e raised to minus RT upon L. This is P, this is Q. Okay. Therefore solution is I into integrating factor is equal to integrating factor into Q dt plus C. Put these values, I into this integrating factor is equal to integration of this integrating factor into Q. Q is this total term dt plus C. Now take E upon L is a constant, e raised to minus RT upon L and e raised to minus 80. Take combine, minus t is a common term, take outside, r upon L plus a is a remains in the bracket, dt plus c. Now integration of exponential is exponential only, divided by derivative of this should be divided. Therefore exponential integration is e raised to minus t into this as it is, divided by derivative of this total term is minus this constant as it is, plus integration constant c as it is. Now take this cross multiplication, we get minus, take in the numerator, r plus al upon L comes to the numerator, r plus al. This term as it is, now split this, e raised to minus RT upon L into e raised to minus 80 plus c. Okay. Now LL gets cancelled, e upon minus e upon r plus al into this as it is plus c. Therefore divide this, this is the LHS side. Now divide this equation by this term exponential, we get I is equal to this term as it is, e raised to this term as it is, this term gets cancelled, this term gets cancelled, plus divided by e raised to minus RT upon L comes to numerator as plus RT upon L. This is the solution. Call that equation number 2. Now we have to find out value of C. So that you use the initial condition at time t is equal to 0, I is equal to 0. Put these two value in the above equation, we get I is equal to 0 is equal to t is equal to 0 means this is this as it is, plus this is 1 plus c into this is again e raised to 0, e raised to 0 is 1 plus c. Now c is equal to, plus take this term on this side, e upon r plus al. Put this value again in the solution, we get I is equal to minus e raised to minus 80 upon r plus al plus e upon r plus al e raised to minus RT upon L, which implies take e upon r plus al common, it becomes this is plus time plus sign, plus term, take first e raised to RT upon L minus this e raised to minus 80. Okay, this is the solution, this should be plus. Take this minus side as it is. Okay, this is the answer. Okay. Now this is the homework for you. If electromotive 4, that is voltage, is given 10 sine t, when I is equal to 0, 10 d is equal to 0, this is but obvious. It is not needed, it should be given. Then find current I in RLE circuit. This is full stop. Equation is not given, we have to solve as usual. It is already solved, just put the value of E is equal to 10 sine t as earlier, okay, in RLE circuit. So I'll just copy the same solution. In the RHS side we have to just put 10 sine t. Answer is this.